k is greater than j is greater than 0. You might start a problem like this with saying something like k equals, I guess, 6, and j equals 5. But we will have to be very careful with that. This is true within the constraints given here, but the end result might be surprising if we use these numbers to model the situations in quantity A and quantity B. First, we'll need to talk about quantity A, which is the time needed to read k words at j words per minute. All right. I'm probably just going to reintroduce you to the idea of rate. If I'm talking about traveling a certain distance at a certain speed and given a certain time, I have a formula to model that. Distance would always be equal to my speed times my time. Okay, a good thing to be real comfortable with. I start the conversation with distance, even though this isn't a traveling problem, because there are other situations that are modeled by a very similar formula. We're talking about getting stuff done, or a machine that produces a certain amount of items in a certain amount of time, reading a certain amount of words in a certain amount of time. Okay, well, basically, in our context, we can swap out distance with sort of words read. Okay, and we can say that that's equal to the speed at which we are reading times the time for which we are reading. Okay, so I'm going to get rid of the distance analogy now. I just wanted to bring that up because it might help, make this problem, this situation, seem more familiar to you if it wasn't already. But words read equals the speed at which you read times the time. Okay, another way of looking at this is in terms of the units. Words equals speed, which is going to be words per minute, times time, which would be measured in minutes. This makes sense because you could, cancel out these minutes and you'd have something sensible like words equal words. All right, so that much has to be true. That stuff has to follow through if you're going to be using a formula like this in your math problem. Well, in general, okay, we're talking about k words at j words per minute. That's a speed. All right, so k equals j times t, or if you prefer, we said 6 equals 5 times t. What is the time needed to read this many words at this many words per minute? Well, we have a singular unknown time. It is being multiplied by 5, so we will perform the algebra and divide both sides by 5 to isolate the t, and we get 6 over 5. Okay, 6 over 5 words, or, if you prefer, if that doesn't make a lot of sense for you, 1.2. 1.2 minutes. Okay, 1.2 minutes. So how did it work out over here? The time needed to read k plus 10 words at j plus 10 words per minute. Well, let me just go ahead and write out the formula that is still going to apply here. Words does equal speed. I'm going to run out of room there. Words will equal speed times time. Once again, we're dealing with k plus 10 words this time. Okay, and that's equal to j plus 10 for a speed, word per minute, times our unknown time t. Okay, and maybe at this point you'd like to plug in our 6 and our 5, right? So that this becomes 16, and that this becomes 15 times time. So we divide both sides by 15, maybe. and we conclude that the time is equal to 16 over 15 minutes, but the calculator says that 16 divided by 15 is actually 1.06 repeating, okay? 1.06 repeating minutes. Alright, well, it would appear that 1.2 is greater than 1.06, right? So I guess we're done here, right? Quantity A is greater. Maybe it sounded like I was about to say not so fast or something like that, right? That this is a trick, that maybe there's more to it. Actually, no, this is correct. Quantity A is greater. But I would encourage you to try certain things on the GRE. Unless you're really familiar with the math and where things are going, then you are vulnerable to tricks like this. So I encourage you to try the weirdest possible combination of numbers that is still within the constraints of the problem. And what I want to do, just real quick, is I want to look at these two equations that represent or that have quantity A and B embedded in them, okay? K equals J times T. Solve for T symbolically. See, this says that T is always K divided by J. Likewise over here, K plus 10 equals J plus 10. I should add that these parentheses are very important. Solving here for time by dividing by the very ugly variable J plus 10. T is equal to K plus 10 over J plus 10. That was a little bit off center. Let me move that. Okay. So I just want to, remind you to try things like this. What is the weirdest possible thing you can think of as far as K being greater than J being greater than 0? How about K was equal to 3 and J was equal to 0.5? Okay? This is the kind of thing that people sometimes forget to try out, and sometimes there's tricks hidden in them. But just to convince myself that I am right on my initial assumption about this problem, with K being equal to 3 and J being equal to 0.5, T is equal to 3 divided by 0.5. Check out that that is equal to 6. Now, check out K plus 10 over J plus 10, which is now 13 over 10.5. Okay, 13 over 10.5 over there on the left for T. And the calculator says that 13 divided by 0.5 is 26. I'm sorry. I meant to say 13 divided by 10.5 is like 1.23. Okay, that was a pretty weird approach to this, but thankfully our answer is still the same as it was before, that quantity A is greater.